Bismillahirrahmanirrahim. Dear students, in this lecture we will talk about sputtering 2. This is Alishan Asif, and today in this lecture we will study about sputtering, basic mechanism of sputtering, and also we will discuss the factors affecting sputtering. So first of all, I want to remind from our previous lecture what is sputtering. Sputtering is a process whereby coating material is dislodged and ejected from the solid surface due to the momentum exchange associated with surface bombardment by energetic particles. Basic mechanism of sputtering. To understand this mechanism, we have to consider an example. First of all, consider an evacuated block attached with an vacuum power. Vacuum power is used to create vacuum. This is done at low pressure, that is 10 raised to power minus 5 atm or 10 raised to power minus 6 torr. Inside the box, substrate is attached at lower side. You must remember that substrate and block are both grounded so that we can remove extra charge in the ground. The target material made up of titanium is isolated from the block. Isolated means that is extracted, separated out from the block. Target material is negatively charged and acts as cathode. Cathode means the thing which gives us negative particles, that are electrons. Target materials is also attached to the grounded power supply, while substrate is positively charged, act as anode. We know that in chemistry, the things which contain negative charge, we oftenly say them cathode, and the positively charged are known as anodes. When argon gas is entered in a measured quantity in an evacuated block, it becomes ionized immediately. The ionization of argon means electrons are extracted out from argon. Argon gives the electrons and it forms a cation, argon cations. The ionization of argon is due to flow of electrons from cathode to anode. Those electrons act as primary electrons. Later we will see what are primary electrons. They are substrates with argon atom. The electrons ejected from target acts as secondary electrons. Electrons moves towards anode while argon strike to the cathode with high energy and sputter the atoms from the target. These sputter atoms strike to the substrate placed in front of target and deposit on it. In this way, deposition of thin film takes place by sputtering. Here in this picture, you can overview the process of sputtering by this diagram. This is our target material. In this case, that we have choose aluminium. These are our argon ions, argon cations. They will strike to the target, aluminium target. This target will eject the electrons. That electrons will this will eject atoms. That atoms will ejected toward the substrate. There they will be coated in this, as I have shown you in this red color line. These are our target atoms. Argon gas is projected from here. This is our cathode, that is actually our target, and this is substrate. This is vacuum, where we have to vacuum all our system, right? This is a simple process of sputtering. This is the basic mechanismic picture of sputtering. Sputter deposition: when an energetic particle strikes on surface, the target, basically surface is our target, a plume of material is released, like the shower of sand when a golf ball lands in the bunker. This effect is known as sputtering and is used to produce films of material as thin as just a few millionths of millimeter. The source of the ions might either be a local plasma, maybe diode or planar magnetron sputtering that you will see in the next lectures. Our separate ion beam source means ion beam deposition source. And this picture you can see that argon ion by created electron impact electrons, then electrons will strike with this argon ion. It will eject its electrons and convert into cations. These cations will strike with this surface and the impact will go down to the lower surfaces and it will eject out its atoms that are basically sputtered atoms of the target material, right? So next, a sputter deposition is a physical vapor deposition method of thin film deposition by sputtering, in which a high purity source material, that is our cathode or target, is subjected to a gas plasma, that is typically argon. That might be possible that gas can be oxygen or nitrogen suitably. The energetic atoms in this gas plasma collide with the target material and knock off source atoms, which then travel to substrate and condense into the thin films. This involves ejecting materials from a target, that is the source, onto a substrate such as silicone wafer. What do you mean by wafer? Any thin piece of a material is known as its wafer. Resputtering. What do you mean by resputtering? Resputtering is remission of the deposited material during the deposition process by ion or atom bombardment. Sputtered atoms ejected from the target have a wide energy distribution, typically up to tens of electron volt, that are 100 to 1 lakh K. The sputtered ions, typically only a small fraction of the ejected particles are ionized, on the order of 1% only, and that can be ballistically fly from the target to straight line and impact energetically on the substrate. What is substrate? The surface on which we have to deposit the film or vacuum chamber, causing free sputtering. Alternatively, at higher gas pressures, the ions collide with the gas atoms that act as moderator and move diffusively, reaching the substrate or vacuum chamber wall and condensing after undergoing a random walk. Here I can explain this mechanism. Sputtering is widely used as highly versatile vacuum locating system used for the deposition of variety of coating materials. Here from this hole, argon gas impinges in the system. Argon gas, when the electrons ejected from these target material, they will strike with argon and convert into argon ions. This was our previous concept. In this concept, oxygen will be added in this situation, and oxygen will, when argon atoms strike with this target material, they will eject it out its metal. Metal will combine with oxygen and form metal oxide. This metal oxide will be ejected, will be attached himself. It will sling himself with the substrate and it will attach in the form of MO2, that is magnesium dioxide. It means it is metal oxide, right? This is the short phenomena. Here you can see that anode is our substrate and our target material that we have to be sputtered is cathode, right? The entire range from high energy ballistic impact to low energy thermalized motion is accessible by changing the background gas pressure. We have to change the background pressure. The sputtering gas is often an inert gas, mainly that is argon, or might be possible that is maybe oxygen or nitrogen or other suitable gas for efficient momentum transfer. The atomic weight of sputtering gas should be close to the atomic weight of the target. So for sputtering light elements, neon is preferable, while heavy elements, krypton or xenon, are used. This is a very simple thing. Reactive gases can also be used to sputter compounds. The compounds can be formed on the target surface, in flight, or on the substrate, depending on the process parameters. The availability of many parameters that control sputter deposition make it a complex process, but also allow experts a large degree of control over the growth and microstructure of the film. Resputtering. This is a very important concept. Resputtering involves re-emission of material, e.g. SiO2, deposited by sputtering during the deposition. Similar to the sputtering, the re-emission is caused by ion bombardment of the deposited material. Now we will discuss the factors affecting the sputtering. Distance between target and sputtered. First, our factor is distance between target and sputtered substrate. First, I want to tell you that there should be a suitable distance between the target and substrate. The distance between substrate and target greatly affect on the substrate of sputtering. It has great effect. As the distance increases, the sputtered atoms take more time to reach the substrate. Thus, their energy greatly reduced due to their collision with other atoms. The sputtered atoms are more unable to adhere on substrate surface. The sputtered atoms move towards target and deposit in it. There should be a suitable distance between substrate and sputtered atom, and also on the target material, so that we have to perform sputtering with better results. Energy of sputtered atoms. As the energy of sputtered atom decreases, the process of pre-sputtering starts and sputtered atoms unable to deposit on substrate surface. So energy of sputtered atoms directly relates to the rate of deposition. Angle of incidence of ionized gas. Angle of incidence that is directly attached with the sputtering mechanism. It is directly closed to the sputtering. Angle of incidence should be from 60 to 70 degrees Celsius, in between 60 to 70 degree. Alright, not Celsius, only degree. If it will be 90, it cannot cause sputtering. If it will be less, 60 to 70, then same. Right? Rate of deposition enhanced at this angle. Mass of sputtered atom. As the mass of sputtered atom increases, their speed slow down and their energy decreases continuously. Due to decrease in energy, the process of sputtering decreases. Due to decrease in energy, the process of re-sputtering starts. Hence, the rate of deposition decreases. What do you mean by primary and secondary knock-on? That is an important concept in sputtering. One argon's ion strike to the target. First atom ejected from the target, reflected, and then again strike to the target. The target atom sputter from the surface. The sputtering of atom from target material during this reflection process is called primary knock-on. Here you can see that in primary knock-on, argon will strike with this atom. This atom will be reflected back, and it will push this atom to do sputtering. This is known as primary knock-on. One second atom gain energy from the incoming argon ion, and adjacent atom low also sputter even due to low energy. This is called low energy or secondary knock-on. Here you can see that when argon attached with this atom, this will grudge towards this and it will eject it out from this side. This is known as secondary or low energy knockdown. Reasons of sputtering. Use large area targets which gives uniform thickness over the wafer. Control the thickness by deposition time and other parameters. Even materials with very high melting points are easily sputtered. Sputtered films typically have a better adhesion on the substrate. Sputtering can be performed top down. First of all, source. This is a simple mechanism. First of all, source. will be evaporated, that is mostly solid or liquid, evaporated into gas phase. From gas phase it is transported and deposited on the solid surface, that is our substrate. Here you can see that target argon ion will be strike with the target. These will eject its atoms, and these atoms, sputtered atoms, will move towards substrate. They will strike towards substrate and they will deposit it on the substrate material. Here you can see the power supply. This is the basic model of the sputtering. Requirements for the sputtering: we require vacuum, inert gas, power supply, sputtering gas. Steps for sputtering: first of all, ions are regenerated and directed at target. The ion sputtered targets atoms. The ejected atoms are transported to the substrate. Atoms condenses and form a thin film. Here you can see that ions, argon ions are moving inside inlet. They will electrons from the sputtering target will target to the argon ion. These ions will argon will become cation. Argon will become ionic, and it will further move towards, strike towards the sputtering target, and it will get back towards substrate, and then ions will deposit on this substrate. Right here you can also see this. This is the cryo pump, power supply, target cathode, wafer anode. Same procedure as I have explained here. Unique characteristics of sputtering: unique thickness over large area. Simple thickness control is very important. The low composition maintains stoichiometry with the original target deposition. Deposition rates do not differ a great deal from one material to another. That is my most important step. Sputtering cleaning: prior to initiating film deposition, we have to clean our material. The surface is not again exposed to ambient after such cleaning. We have not to spore the surface when we have to do the sputtering. The lifetime of a sputtering target may be as long as 100 of runs and seldom less than 20. Thanks for watching this video.